Did you know that you use around 100 rolls of toilet paper each year? Now, take into account that in the United States of America alone, there are 331 million people. That's a lot of paper. Each year, over 24 billion newspapers, 2 billion books, and 350 million magazines are published in the United States alone. So, how is all of that paper made? The production of paper obviously begins with securing the key raw materials: wood pulp from trees and recycled fiber from used paper products. Trees like spruce and pine are harvested from forests and transported to the paper mill facility. Debarking the trees is accomplished using a machine called a ring barker that scrapes bark off using various blades at extreme pressures. Here they undergo debarking to remove bark before getting chipped into small pieces to start breaking down the wood. They use paper materials collected for recycling, including cardboard, newspapers, and office paper, are repulped mechanically using water and pulping actions which return the paper to separable fibers. Whether it is pulp from newer trees or recycled fiber, both undergo a pulping process to further separate the fibers needed to make paper. Mechanical pulping uses grinding devices and equipment to physically tear apart the fiber connections through intense mechanical action. Chemical pulping involves cooking the wood chips or recycled papers in chemical solutions to dissolve away binding materials, like lignin, and leave freer cellulose fibers available. The pulping method utilized depends on the paper product's quality needs and intended applications. Both processes result in paper pulp with increased fiber availability, ready for the next steps of paper formation. Bleaching is an optional process in paper manufacturing that lightens the natural light brown color of unbleached paper to achieve whiter or brighter paper products. It is commonly used when producing printing paper, writing paper, packaging materials, and other paper products where brightness is desirable for aesthetic reasons or to improve contrast and ink acceptance. The bleaching process involves adding oxidizing chemical agents like chlorine dioxide or hydrogen peroxide to the paper pulp mixture. These chemicals extract residues like lignin that give unbleached papers their natural darker color. Removing these residues increases the paper's ability to reflect light for enhanced brightness and whiteness. The intended application of the final paper product ultimately determines whether performing bleaching is an essential manufacturing step or not. Paper begins forming when the pulp fibers are mixed with over 99% water to make a very soupy liquid called paper stock or slurry. This fluid mixture gets poured onto a moving screen cloth belt that lets water drain out from the bottom. As more water drains through, the pulp fibers start crisscrossing to form a wet mat of fiber on top of the screen, similar to lots of tiny cellulose straws overlapping. The fibers bond during this wet paper web formation stage to create structure. Underneath the screen cloth are suction boxes that also help pull water out. Operators can adjust the slurry flow, screen speed, and other settings to influence how tight the fibers bond as the wet paper sheet is produced. Eventually, it builds up into a thin, wet mat of overlapping pulp fibers that become the paper itself after it's pressed and dried. The paper web next enters the pressing stage, where the objective is to remove even more water from the newly formed wet paper sheet. This increases the paper's density and mechanical strength while reducing overall bulk. Pressing is accomplished by passing the damp paper web through a series of heavy rollers that squeeze out excess moisture. Older paper machines utilize a whole series of press rolls that apply substantial pressure to the paper sheet as it passes through. More modern machines may instead use extended nip presses, incorporating a lubricated felt that transfers force over a longer area for enhanced water removal. The gradual pressure applied across the paper web during the pressing stage removes water to prepare the paper for the final drying stage. The pressed paper sheet then enters the drying stage, where the objective is to completely eliminate any remaining moisture before it is wound onto master rolls. This drying process transforms what is still a damp paper web into finished dry paper ready for cutting and processing. Paper drying relies on the application of intense heat from steam-heated dryer cylinders and rolls. As the press sheet travels around these hot metal drums, the heat evaporates the remaining water in the sheet through contact and convection until the paper coating the drying cylinders emerges dry. Monitoring moisture levels through the drying stage allows for exact drying tailored to the paper's thickness and specific water content. The drying stage's efficient water evaporation yields the final paper product ready for finishing steps. Calendering is an optional finishing process that further smooths and modifies the paper surface for applications requiring a glossy appearance or enhanced printability. In calendering, the dried paper sheet passes through a set of hard pressure rolls, which compress the paper web and smooth out its surface texture. The pressure applied during calendering reduces pitting and smooths fibers within the paper sheet. Calendering would be used in production of glossy paper for magazines magazines, posters, and brochures, as well as coated papers for high-quality printing. The resulting surface improves reflectivity, opacity, and print quality. However, calendering is unnecessary for uncoated copy papers or tissue products, so it is an optional stage based on the desired outcome. After the paper has been formed, pressed, dried, and possibly treated in additional stages, the final steps are cutting the dried paper rolls into usable sizes and packaging them for transport. Special cutters slice, trim, split, and rewind the paper into different widths and diameters, depending on what it will be used for. Trimmers make precise cuts needed for applications like copy paper, while rewinders rewrap large rolls for industrial uses. The cutting and finishing stage also does final inspections for defects before packaging. Folded paper goods may undergo additional corrugating, creasing, and folding steps as well. The finishing work turns monster paper rolls into neat packages of all kinds: copier paper, notebooks, tissue boxes, and more, ready for shipping to distributors and end-use consumers. Now you know how paper is made, but before you go, here's a trivia question to challenge you. On average, how many pieces of paper will one pine tree produce? Is it 1,799 pieces? Is it 40,045 pieces? Is it 80,329 pieces? Or is it 123,090 pieces? If you guessed 80,329, you were right. All that paper comes from one pine tree if this efficient process is followed.